Okay, so let's explore if in our STL file we have multiple patch name. Okay, so till now whatever we look at mesh generation, in one STL file we have one name of entire boundaries. Okay, so let's explore if we have multiple name. Okay, so if we have multiple name, then how to proceed. So let me show you the first file. Okay, so here in the .stl file we have multiple patch, like patch equal to 0. Let me check how many patch we have. Then here first patch end and second patch is started, patch number 2, patch number 2 is end, and patch number 3 patch number 1 is starting and patch number 1 is ending. So in total we have total 3 patch here. Okay, so let's, if we want to create a mesh for this class of geometry, then how to proceed. Okay, so let me quickly show you how you can do that. For let's say we start with our as usual command. So first go to the area here, okay, and let's first clean the case. Okay, block mesh. Okay, first let's finish the mesh. Okay, then we go back to the snappy hex mesh dict file. Okay, so if you go to the now snappy hex mesh dict file, okay, here, so here everything is same setting: castle mesh true, snap mesh true, add layer true. Okay, then in the previous case we in the STL file we have only one patch, so we didn't define the different zone or region of that particular patch, but right now we have patch number 0, 1 and 2, and we gave the internal name as a wall surface 0, 1 and 2. Okay, so this is how you can change the name. Okay, and this is our refinement box as it is, but later on with the help of this name you have better control of applying the different number of layers on different faces. Okay, so that is the idea behind that. And you also have a chance to refinement surface area, give the different refinement for different patch. Okay, here right now I am giving everyone as the same refinement, but you can change it and check how the different refinement is affecting, and when you change what it's changing. Features we kept is 60-degree angle. Okay, then till we are not using this refinement box, later on we try to use that. Okay, location of the point, make sure this location is the point, location of this point is either it is inside mesh, then it's supposed to fall inside of the STL file. It is external aerodynamic type of calculation, then this point supposed to outside of the STL file. Okay, so make sure that. Then this snap control, fine. Then we have a add layer control. Okay, so we define certain things, and here for every patch we define the 5 layers. Okay, and it try to create the layers for each one of them. Okay, so let's say we have a different patch, and on the different patch we are getting some different layers depending on the size what we specified. If we require exact layers, then we have to tune certain parameter in this area. Okay, this one, either use this first cell height and try minimum thickness area, and if you use this, and we going to get a proper mesh out of it. Okay, so let's see how exactly the mesh is look like. So if you look at here, in previous case we have only one patch, now we have multiple patch. So let me open, this is the patch number 0 and this is its size, then patch number 1 and 2. Okay, so this is its size. So this is how we can compare or control the layers on, or control this distribution of mesh on different patches. Okay, so this is very straightforward, but make sure you have a separate name while you are creating the STL file from the geometry. Okay, so inside the geometry you give the separate name, and based on that name you will see all the required information inside the STL file, and then you try to plug that zone region inside of this geometry area, and you have better control for that. Okay, so let's go to the next tutorial from this part, and let's see what difference we have. Okay, so let's say case 2. Let me open the file. Okay, so we have a different patch here. Okay, but certain change I am proposing here. Let's say on one particular patch we have a different layer. Okay, levels. That means we are refining the patch number 0 little bit on a higher side as compared to the patch 1 and 2. Okay, and all other setting let's keep same. Okay, here I also change the number of layers for different surfaces, different number of layers. Okay, so each surface is a different layers, and we try to resolve the each surface with the different number of layers, so that is the better control. Okay, so let's try to run this case very quickly, and let's explore how exactly it's look like. Case number 2. Okay, so we are creating the mesh with a different surface refinement for patch number 0, so you don't see the same mesh what we observed in the previous case. This time we have a different mesh. Okay, so let me open the first case. So we have that is base mesh, and we try to compare with this. Let's go to the last one. Okay, we have a entire geometry mesh. Okay, let's cut the domain. So this is the first case where we have a same number of surface refinement. Okay, and let me show you. Okay, I cannot switch off and switch on different thing at different area, no worry. So I want to show you the layers here. Okay, so this is our cross section, and on that cross section we are seeing the layers. So this is what we seeing at this point. Okay, why we don't have that layer refinement properly? Because of this setting. Okay, so let's see how we can capture the mesh properly. Okay, so let's switch on here. Let me put it this thing here, and here we open the our new case, so we have idea what is the difference we have. So this is for refined version of the layers. Okay, and let me copy this file from this area to here, so we able to open both the mesh at a time. Okay, so let's open the second one. Okay, so this is the second one, and this is how the things look like. So first let's explore all the surfaces, so we have an idea. Either we have a different mesh on it or not. Okay, so on the different surface we supposed to have different mesh. In the previous case we didn't refine the mesh, so here for the patch number 0 we gave the level equal to 4. So here we getting the refined mesh for patch number 4. Okay, so and we have a different layer on different edges. So let's quickly look at the cross section for this particular mesh. Okay, first let me activate the internal part, then we able to cut the mesh. Okay, so this is our internal mesh, and we want to cut domain to locations, don't want triangulate surface, and this is what we want to see. Okay, so at different location we have a different element. Look, on the surface number here 0, that is the path 0, that is the peripheral surface, we have a 3 element, okay, sorry 5 layers. So here we have that many layers on that particular edge surface. Then on one side we have a 3 layers and another side we have a 4 layer. Okay, so that is how on one side 3, one side 4. That is how you can give a different layers, and accordingly we will get a different value for this. Now let's go to the next one case. Okay, so let me open the files. So we have everything same, we are not changing. We also we are moving from this version to the next one. Okay, so what changes we are observing is features is same, okay, but here refinement box. Okay, in the previous case we didn't keep the refinement. If you don't give the refinement, okay, in the case, then what going to happen is something like this way. Z. Okay, so let me show you. This is without refinement, without activating this refinement box. Okay, now we are applying the refinement box has a higher value. Okay, so if we do that, then the following change you going to observe here. So I am right now at the third case. Okay, and let me quickly create the mesh for that. Okay, so we define the refinement box here. Okay, where in the geometrical area. Okay, refinement box size is -2, -2, -2. Okay, so let me quickly give you the idea about that. Okay, so if you look at here, then this is our geometrical dimension. Okay, so we kept the from one point to the point another corner point. So if I want to, let's say this is my refinement box, so I require this point and this point, I construct this refinement box. Okay, in the similar line here I gave the mean and max to corner point of the box. Okay, that means any corner point you can give diagonally opposite to corner point, and it try to construct the refinement for and what it going to do, it's we going to observe very quickly. Okay, so with that refinement we able to refining the finer mesh in this particular zone. That is the idea behind that. Okay, so let me quickly copy the required file. So it just the snap max is over. Now the layering is going on. Okay, so after that we get our required mesh with the activated refinement box. Okay, so when we activate this refinement box, we created it. In till now we in all the cases the box is available. Okay, but we didn't give the layer within that box. Okay, till now we gave the layers based on the surface refinement. Okay, but we didn't use this zonal refinement, but this time we are giving level equal to 2. Okay, and here we are going with the inside option, so this value is doesn't affect. Okay, even at a distance level when you go, then only this value going to affect. That means from this particular zonal box at a what distance you required the finer value. Okay, so it meaning like that way. Okay, so let me quickly open the third one file. Okay, so this is the third case, and we want Z normal. Here I don't want this, so this is Z normal, and if you look, this is the difference. Here we don't have a zonal refinement. Okay, and here we have a zonal refinement. So this zonal refinement, with the help of that you can construct n different class of the zones. Okay, and slowly you can create a very nice mesh that will give us the capturing of or the vertex shading, everything that will trigger because of this obstacle. Okay, so this is how you can refine the layers as well as define the particular zonal values. You can give a different layers to the different surfaces. Okay, so all this thing you can control. If you have multiple patch within your STL file, then that give you the better idea. Okay, so let quickly show you that our previous features what we look at. So in this, let's say we want to see for different patches the different thickness and all values, so we are able to see here very quickly. Okay, and let me activate this all. Okay, so on this particular thing, let's look at the N surface. Okay, so at different surface we gave the different layers. So you observe this color showing you we have maximum layer equal to 5 on this surface, and even at some places we get a lower value of layers. Okay, so with this distribution we come to know where our layering is failing and all this thing. Okay, so we can rectify also. And here is the thickness. Okay, so in which zone what type of the thickness of the layers we are getting. Okay, so it gives us the at least first hand idea. Okay, whatever we are expecting the thickness, because this wall thickness and the number of layers is very important when we are going towards external aerodynamic. Even for internal flows, wherever there is a solid wall, we must have these layers. Okay, if we don't have a layer, we're not able to capture boundary layer properly, and all heat transfer and everything will be way off from for the comparison point of view. Okay, so this is the few things one can explore from this point of view. Okay. So basic things we cover. Now I have one assignment for you. Okay, so till now whatever we cover is from 01 to 04. Okay, so let's look at my surface 1. Okay, so what I want is following thing. Let me first show you few things here. Okay, then I will suggest you what you're supposed to do with this surface. Okay, so we have a one surface, and let's observe how the surfaces look like. So try surface, and I created one surface. Okay, so this is arbitrary class of the surface. Look, okay, and it has a one continuous surface, so we don't have a separate name for different surfaces. Okay, what I want, you can repeat each and every tutorial what we did in each of this part. Okay, step by step construct each and every one for this and try to construct a nice mesh. So I am giving you only this STL file. Okay, and with the help of this STL file, so here is this dimension. Okay, and flow is approaching from here positive x direction and passing through this obstacle and going in the downstream directions. Okay, so if I see, this is the patch look like. So from left hand side flow is entering or approaching this obstacle and going from and passing through this obstacle and going in the right hand side directions. Okay, so construct a appropriate domain with the help of the block mesh files. Okay, and try to generate step by step very nice mesh for this. Okay, so this is a very nice tutorial. So with the help of that you can able to execute or whatever you learn, try to apply here straight away. Okay, so please do that. In the actual file I am not going to give you all this setup files. Okay, so you will not going to get any setup file. I will only keep this try surface, and inside of this you have this one surface file. So I am keeping inside of this folder only this file. Okay, you use this file and readme file, both the things with you. Copy the setup from other area and start working with this STL file and try to finish 1 to 4 each and everything for this one surface. Okay, please do that. So till now what we look at is the something like external flow type of the calculation. So let's quickly go towards internal flow type of the calculations, where we try to do the meshing for something like mixing elbow class of the 3-dimensional domain. Okay, so let's first go to the area and try to explore how the STL file is look like. Okay, so here we are, and let's first look at the STL file. Okay, look, until unless you have some meshing, it's always give you the error. Okay, so don't worry about that part, but straight away go to the try surface and look at the STL file how look like. Okay, so this is our geometry, and for this geometry we have to create a nice mesh. So here we have a inlet 1, inlet 2, and outlet, and this is, I think, pipe is the name for that. So let's look at inside the STL file how look like. So let's try to search this name. So solid inlet 1, then pipe is outlet, entire this bounding pipes, okay, including this bigger one and the smaller one. Okay, then we have a inlet 2, that is this small inlet. This is inlet 2, this is inlet 1. Okay, then we have outlet is at the top. Okay, so this is the outlet. So we have to now construct the internal mesh. Okay, so mesh, we have to look at the flow through this particular geometry. So how to proceed? Idea is very simple. First we have to construct the entire bounding box that will cover entire of this particular geometry. Okay, so that is our starting point. So let's look at the block mesh first. Okay, so we are constructing the block mesh. So let's see how the mesh is look like. So this is our block mesh. Okay, entire block, and inside of this block make sure our STL file is within this particular block. Okay, so if you look at here, this is the look. So the block is very big, but no worry. Okay, because we afterwards we going to, when we start creating the mesh, it's only going to create the mesh whatever the cell is cutting this surface. Okay, so no worry, even though you have very big box size. So but make sure you have a look each cell. Okay, whatever is near to the surface, make sure each cell aspect ratio is supposed to be 1. Okay, so that is the good starting point for this class of mesh generations. Okay, so then let's look at few thing very closely here. So we require the internal mesh, so few changes we have to do in the snappyx mesh file. So we require the layers also, so it is there. Okay, what change we required? We required, first of all, we make sure that this location in mesh supposed to be fall within the our STL file. That means this point supposed to be lie within the that elbow geometry. If it is outside, then it will try to construct the external mesh. If we want internal mesh, make sure this point is within the our STL file. Okay, and let's observe few more things. So we want added layered class of mesh as well, and this is the surface mesh surface file we are reading, and it's we are giving the name as a mixing elbow. Okay, look, either you give the separate name for, let's say, pipe, we give the pipe as a name. In the same way, if we look at the here our STL file, okay, again let me open, we have a inlet 1. Okay, you can define here also same way, zone 1, and you can say inlet 1 equal to inlet 1. Okay, or you don't want to define like this way. Okay, then easiest way is something like this. We give the entire surface as a mixing elbow. Okay, and whatever the zonal name you give, it apply that name. Otherwise it will go underscore inlet 1. Like that way you can specify, means it is the by default way to generating the names inside the this snappyx mesh files. Okay, so when we execute, you will understand. Then surface features definitely we to extract, then only be able to give a very nice mesh on entire circular outer pipe and everything. Okay, then mixing elbow, surface refinement. So we gave this zonal based refinement, because we know that the one is the pipe. So for the pipe we gave the refinement another, as I told you, if you gave separate name here, where here inlet outlet, inlet 1, outlet 1, like that way, or you can give global name and automatically it construct the name like mixing elbow underscore inlet 1, okay, for inlet patch, like here mixing elbow underscore inlet 1, mixing elbow underscore inlet 2, and the outlet. If you gave name here inlet outlet, then you have to modify here as a inlet 1, inlet 2 and outlet, okay. So based on your understanding, you can change it either of the ways, okay. If you want to go with the default way, then give the default name and immediately whatever the name is appear inside the patch, it will automatically add up that name and it will show here, okay. All the setting is more or like same, okay. We are not changing anything here. At layer we have a relative size equal to false, because everywhere we require the same element size, okay. Then we have a number of elements. You can go with different number of element for different patches. We don't require anywhere element, we require element only for the outer pipe, so we give layer equal to 3, okay, and all other setting let it be same, okay. So like that way if you do, then we able to get a very nice mesh out of it, okay. So let's quickly first generate the mesh and have a feeling how exactly it's look like. So first let's clean everything one more time. So we extracting the features as well. Okay. Now look, here is the name. Wall, we gave a particular name, so that's why it's appear like a pipe, okay. If you don't like this name, then where we define the pipe, same way you define inlet 1, inlet 2 and outlet, and then we don't have this name. But right now it is automatic name, like patch type, mixing elbow and different zone name they are specifying very quickly, okay. So this is how you can there is a multiple way you can control the things, okay. So based on your understanding or requirement, you can trigger the different name, okay. It is giving us the internal mesh very nicely, okay. So let's wait for 1 minute or more, let's see. So this is what we gave the pipe, and on the pipe we gave the layers, okay. So we get the layers only on the pipe surface. So let's quickly check how the mesh is look like, okay. So this is from where we started, okay. So this is our first mesh, then immediately after castled we created this mesh, okay. So sorry, first go to the first one again, then let's go to the second step. So after the castled mesh over, we get this mesh, okay. Then after the snapping we get this mesh, and then finally after the layer we get this mesh, okay. So let's look at this is how we get a very nice layer on these surfaces, okay. So this is how we can construct the internal mesh very quickly. So everything is same, okay. Only changes is at one place in the SnappyX mesh file, that is in the castle mesh control. You have to make sure that our this area sorry, not area but the point is lie within the entire of this surface, okay. If we don't give that, then it try to construct the external mesh, okay. So this is how the mesh is look like. So let me show you the internal mesh, okay. So this is entire internal mesh, how the mesh look like, okay, with the layers, okay. So this is how one can construct the internal mesh. I will give you one very quick assignment with that, okay. So here I will give you one STL file, that is 3D pipe STL file, okay. You have to add up this mixing elbow test case and try to construct your own mesh with this 3D STL file. But here we have a multiple names. Like if you look at the peripheral entire wall of the pipe is the wall. Okay, then let me show you very quickly what different name we have. Then we have outlet, and then we have an inlet. Okay, so three patch different name. We require the very nice mesh flow through a pipe. It is 3D pipe. Okay, so we try to generate very nice mesh. We have to adapt the similar setting what we have at the mixing elbow level, and we try to construct very quickly that class of the mesh with the help of that. So please finish this tutorial. Okay, I will give this file, and you have to construct the entire mesh, internal mesh for 3D pipe geometry. So till now we explore the three-dimensional internal as well as external mesh. Okay, but let's say we want to construct the mesh for two-dimensional calculations. Okay, so by default this SnappyX give us the three-dimensional mesh only. So but there is a way you can construct the two-dimensional mesh as well. So let's quickly look at the flow over a circular cylinder one case and try to construct a two-dimensional mesh for this class of flows. So let's quickly observe that. Okay, how we can construct the two-dimensional mesh out of it. Okay, so for that let's first go to the working directory. Okay, and first check how our geometry is look like. Okay, so let's quickly show you. Okay, so this is the cylinder. Okay, and we require the two-dimensional mesh for this. Okay, so if wherever you require the two-dimensional mesh at that point of time, it is not necessary that entire of this cylinder, that means Z direction, is covered within the block. Okay, because we want only one cell thick mesh in the Z directions. Okay, so here our blocking strategy is something different. So let me run the block mesh file. Okay, and show you the mesh block mesh. Okay, so if you look at here in the block mesh, in the Z direction I didn't give any of the element. That means in the Z direction I gave only one element, and on this let's open our surface so you will understand. Okay, so look, our cylinder is not completely covered by the block is cutting this cylinder. So whenever you require the two-dimensional mesh, this is the approach. Whatever the obstacle or whatever you are hoping, okay, try to cut through that particular domain. Okay, so that is our starting point, and make sure we have a regular aspect ratio cells near the surfaces. Okay, and at least one of the cells supposed to cut the surface. That is its requirement. Okay, so as usual, first create the entire mesh. Okay, so there is no difference in creating the mesh. As usual, we try to create the mesh with our regular all the commands. Okay, so let's generate the first mesh. Okay, and see how the mesh is look like. Let me show you meanwhile the snappyhexdix file. So we are adding the layers as well. We have a cylinder all STL file, and we gave no any zonal because every surface we have a only single name for the surface. Then refinement box, if we want to use later on we can use that. Okay, then we need not to capture these features. Okay, because not required here. Then we gave the surface level refinement levels to capture the surface nicely. Resolve features equal to 30 we gave. Okay, this zonal refinement we didn't kept right now. Okay, snap control same, add layer, relative size let it be true. Okay, and then we are adding the 5 layers. Okay, you can add more layer. Features angle equal to 130. It not going to harm here. Everything is same. So let's look at the mesh. Look here, we able to add the 5 layers. So go at the end and see how mesh is look like. Look, so this is the mesh what we constructed. Okay, but if you look at the mesh, it is still 3-dimensional. Why it is 3D mesh? Because look, in the Z direction inside the cylinder you have multiple layers. Okay, but when we want two-dimensional mesh from z direction, we require only one cell like what we have here. Okay, but here we have multiple cells, so that not allow us to run in the two-dimensional way. That means in the z direction, whatever the patch we have to keep, let's say, front and back empty. Okay, so it is not possible right now because we have multiple points here. Okay, so this is how one can quickly construct the mesh flow over a circular cylinder. But we are interested to create a two-dimensional mesh. So for that, first we have to copy this mesh inside the polymesh area. So let's do that. It is mesh number 3. Okay, so castle mesh, snap mesh, and layered mesh. So mesh number 3, first we copy inside the or polymesh area. Okay, so we are doing that. So now we have a mesh inside the polymesh. Then we have a extrude mesh options. Okay, so before we go towards extrude mesh, let's look at the mesh. So now if you open this, immediately you get our mesh straight away, because now we loaded the mesh inside this. Okay, and let's explore few more things. We require the front and back. Okay, so this is the front and back. Okay, so that whatever the along the direction over which we require one cell, we require the name of both the patch. Okay, and that name, with the help of that name, we try to use this extract mesh utility. Okay, in the extract mesh, we require the source patch equal to front, and okay, and the exposed patch equal to back side. So either of these thing you can do, one front, one back. Okay, and then we require layers number equal to 1 only. Okay, so make sure layer equal to 1. Okay, and thickness is fine. Okay, no worry. So this is very, very important. So layer number, if you give more, then it's going to generate more layer within this, but we require only one layer. Okay, so it is like to extrude the mesh from one side, that is our source side. Okay, so source patch equal to front. From the front side, it try to from here it try to extrude the mesh towards the back side. Okay, so that is the idea. So when you do that, what change we observe? Let's see. Okay, so if we execute this command, okay, so when we did this command, okay, so let's go to the paraform. Now if you see our mesh, okay, so in the z direction we have a one cell thick mesh, and front and back everywhere we have one cell thick only. So we able to give very quickly the two-dimensional concept on this mesh. Okay, so this is how you can construct two-dimensional mesh very easily. So this is almost cover entire aspect of snappy hex mesh. Okay, so we started with the very simple way of creating the mesh, and slowly we add the complexity, and we, with the help of the different tutorial, we try to explore how we can control different things with the help of the different tutorials. Okay, so let me quickly show you one command that is very important. Okay, so this remove zero face patches, this command is very important sometime. Okay, if we are facing some particular patch. Okay, but for that we require certain entries inside the system folder. Okay, so create patch entry, let me figure it out where it is. Okay, so mixing elbow, maybe we require that. Okay, so create patch, yes. Okay, so we must have this one file. Okay, so let me again run this mixing elbow case. Okay, and because I want to show you one particular portion from this, because that is very important. So now if you do check mesh with latest time, okay, so when you do check mesh with latest time, look, we will have a certain more patches. Okay, but it doesn't possess any face or any points. Okay, so this is not a good way, because why it is there? Because we first have a bounding box, and within the bounding box we started creating the elbow mesh. Okay, so we must remove this class of the patches. So for that this is the command. Okay, so if we run this particular command here, okay, then it able to delete all the patches which has a 0 entry in it. Okay, so now after that, okay, it showing us directly on the polymesh, so that's why we not able to see here. So let me quickly copy first this file, okay, and then we go towards that thing. Okay, so what I do, I will run the snappyx mesh again, okay, with the overwrite options. So we directly able to create the mesh inside the inside the polymesh only, okay, and then we try to run this command. Okay, so we are overwriting the mesh inside the polymesh file straight away. Okay, so let's wait for few moment, and then we try to remove the patch. Until unless you copied the files inside the polymesh, we not able to remove that unnecessarily patch. Okay, so that's why it is retained even after we run the command. Okay, but let's see. So right now we have a mesh file straight away inside the polymesh area. If you look at, we don't have anything, and then if you run this, let's say check mesh, okay, if you look at, we have a 0 patch here. Okay, now if you do that, look, it try to remove the all these patches. Okay, and then if you do the check mesh, we have a actual patch on which we have to specify the boundary conditions. Okay, so this is how one can use this last command. Okay, so create patch option, and for that we required this empty directory here, nothing else. Okay, so you copy this directory wherever you face this problem of multiple patch that is unused. Okay, so you have to do the things by this way. Okay, this is how one can work with the snappyx mesh. So I hope it will be useful to you to generate the very nice mesh.